Okay, since we're going to talk about solving equations, let's just go to the very basics and make sure that we're good with it. Okay, and it starts out with what we call inverse operations. Okay, I want you to put this into your own words. What do we mean by inverse operations, if you were to explain that to somebody?
Like the opposite of the thing you're doing. Like
Okay.
the noun.
So she's using the word, instead of inverse, she's using opposite. What do you think, Diana?
Well, I'm not quite sure if this is right, but like a different way of operation.
Okay, so if I said adding, what would be your different?
Like opposite. Well, yeah, basically she said subtract.
So to you, the opposite of adding is subtracting, so the different of adding is subtracting?
Yeah.
We all have to be on the same page. So what do you guys think?
No.
Anybody else? Any other ways, phrases that you would use? All right, so it sounds like most of you are saying the idea is using the concept of the opposite operation, okay? Big thing that you have to understand is that inverse operations, they undo each other, okay? What do I mean by that? Well, let's say I start with x. If I were to add 2, how can I get back to x? I started with x, but I added 2 to it. How can I get back to plain old x? As in, how can I get rid of the plus 2?
We have to do equals.
What would be, in your words, the opposite operation to adding 2? How about if I subtract 2? Notice that adding 2 and subtracting 2 undo each other. They cancel each other out. And I'm left back to what I started with, which is just x. Okay? So just make sure you understand, if I use that phrase, inverse operations, because I will use that phrase instead of opposite operations, okay, that you know what I'm talking about. Okay? So if I said the inverse operation of adding, you would say is what? Minus, subtract, okay? The inverse operation of subtracting is? The inverse operation of multiplying is? And the inverse operation to dividing is? Multiplication, okay? So make sure you understand those ideas, okay? Questions so far? All right, so let's zero in on the very first example, A, okay? And I want to make sure that we're very specific when we do this. And the reason why we're going to do this is because, like, for example, I don't like what we have here. When we get to tougher equations, your basics are going to be very important, okay? So if I look at the x, my goal, my overall goal is to get the x by itself. Well, right now, I am adding 7 to it. What would be the inverse operation to adding 7? Yes?
Minus 7.
Minus 7. So I'm going to subtract 7. And then I am going to subtract 7 to both sides. Why both sides? Think about like a balance. Okay? If I have x over here and x over here, if I add weight to the left, how do I keep the balance? I have to add weight to the right. If I take weight away from the left, how do I keep it balanced? I have to take away the same amount of weight, right? So if I take away 7 from the left side of the equal sign, I have to take away 7 from the right side of the equal sign to keep that balance, okay? Some of you in junior high might have had a teacher that said, like, draw a wall through the equal sign.
Oh, yeah.
Did anybody ever have a teacher that did that?
Yeah.
And then if you subtract 7 on one side of the wall, you have to subtract 7 on the other side of the wall. If you want to do it that way, you can. That's up to you. Overall idea, though, 7s cancel. What are we left with on the left side of the equal sign? Not -3 on the left side. What are we left? X on the left side. Then we've got our equal sign where the wall is, okay? And now I've got 4 minus 7, which is
Negative three.
-3. So I'm over here, I'm gonna say x is equal to -3. Oh. All right, so over here, it has a little check mark, okay? So what we're gonna do is we're gonna check our work. And the way that we're gonna do that is we're gonna basically plug it into our equation. So if x is equal to -3, I'm gonna write -3 plus 7 is equal to 4, and I'm gonna show that that works. What is -3 plus 7?
Four.
Or what's 7 minus 3? 4 equals 4, so check. That's good. If these two numbers didn't work out to be the same, then that means our x value is wrong, okay? So it's just a good check, you know, and the reason is some people make simple mistakes. I've seen people do 4 divided by 4 is 0. I've seen people do 2 times 3 is 5. I've seen people do, you know, 10 plus 2 is 13. You know, I've seen different things. So it's always good to just kind of check it and plug it back in, okay? All right, so this is an example of using addition. So B, what would be our inverse operation if the -6 is sitting next to the x? Diana, what do you think? The -6 and x are sitting next to each other. What operation is being performed right now? Multiplication. And what did we say at the top of the page is the inverse operation of multiplication? You can look in your box up at the top.
Divided.
What's the inverse operation of multiplication? Are you saying that because she said it, or you agreed? Okay. So we're going to divide by -6, and we're going to divide by -6. What is -6 divided by -6?
A positive, positive one.
+1. So these cancel and become a 1x. Do I need to write the 1?
No.
No, I can just write plain old x, okay? Then I've got 48 divided by -6. Can anybody simplify that? I heard 8,
Negative eight.
-8, okay? And this is why it's important that we check, okay? If you had said 8 instead of -8, when you go back to check, if you had done -6 times 8 is equal to 48, does that make sense? Can a negative times a positive equal a positive?
Yeah.
No.
No,
Hopefully from chapter 1 we learned that the 8 has to be negative. Now a negative times a negative equals 48, and 48 equals 48. Yes?
Can you just look at the problem and just be like, oh, 6 times something equals 48, and just write -8. I don't do like all the steps you do. I just like look at it.
Okay. And I completely understand with what you're saying, but here is the thing. We are practicing a skill. So, if you believe this is super duper easy, I want you to do this one.
I didn't say it was easy. I'm just saying I look at it and then I just do the same thing all the steps.
So, if I gave you that problem and asked you to solve, would you be able to do that?
Yes. Yes.
Yeah?
Yeah.
Like, pass, fail. You get it wrong, you fail the class, you gotta start all over again. You that confident?
I'm like 70%.
Okay, and so this is why, okay, I'm just trying to make a point here, is that I know that today is gonna seem very tedious, it's gonna seem like super duper easy, and like Ron's sitting here, he has the answers to all of them because he's just doing it mentally. I get it, okay? But what I wanna do is I wanna make sure that we're practicing the skill and making sure that we understand the skill, okay? So that when we get to these tougher ones, by the end of the chapter, you will all be able to do this problem. Like, no big deal. It'll be like a piece of cake to you, okay? But we gotta make sure that we're good with our basics, okay? All right? So the other thing too is, take a look at the back. Are the ones in the back as easy mentally?
No.
No. So again, we gotta just practice that skill, okay? All right. If you think it is so easy, C. is a very, very, very common mistake. What are we gonna do on C? Because this is what I see all the time. Aaron just said it, subtract 7 to both sides.
No,
I see a couple people shaking their heads, yes. And this is why they do it.
no, it's not.
Stop. They say subtract because there's a plus sign in front of the X. Is that correct?
No.
So what's wrong, Aaron? What should we do?
Add 7.
Why do we add 7 when it says plus X? Because the 7 is negative. We have to do the opposite on the 7. So the opposite of the 7 makes plus 7, that cancels out, and now X is equal to 19. Okay? So you have to be very, very careful there.
Why can't you just do -7 plus -5?
Oh, okay. So he says X should equal -5. All right, so this is why we have our check. -7 plus -5 is equal to 12. If I lose 7 yards and then lose 5 more yards in football, how much did I lose altogether? I lost 12. Does -12 equal 12? No.
So, but same signs
Same signs, add, and keep. That is correct.
No, but thought if you had 2 negatives.
When you're multiplying, when you have 2 negatives, they multiply to be a positive. A negative times a negative is a positive. So remember, we got 2 different rules based upon the operation. Adding, you add and keep. Multiplying, 2 negatives make a positive. Okay? All right? So if you had said X equal to -5, that would not have worked. Okay? But now if we check our 19, is -7 plus 19 equal to 12? Well, different signs, we subtract. What's 19 minus 7? 12. 12 equals 12, and now it works, and X is equal to 19. Okay? All right? D. Cross C. What should we do for D? You want to divide by 1/4. All right, so he is correct. If you don't see this, he says this is a 1/4 X, so he wants to divide by 1/4 and divide by 1/4. That is correct, but there's an easier way. Let's not do it this way.
Flip it.
Do you know what to do?
I do.
What's the opposite of what's happening with
4 over
our X?
1.
Stop. Part of the reason why I'm asking different people is I want to check with different people. So please do not shout out answers. Okay? So, if I were to ask you, what is going on with the X right now? Would you say that we are adding, subtracting, multiplying, or dividing? We're dividing. What's the inverse operation to dividing? So, if right now we're dividing by 4, you just said the inverse operation is multiplying, what should we multiply by?
By a number.
If the inverse operation to dividing is multiplying, we're dividing by 4, we should... Marisol? Multiply by 4. Would you say the opposite of dividing by 4 is multiplying by 4? Does that make sense? Okay, so we're going to multiply by 4, and we're going to multiply by 4. Is that what you were going to say? Roxana? Okay. All right, so now, these 4's cancel. Whoops. I don't know what's going on there. Let's see. All right, so multiply by 4, the 4's cancel. X should equal what? 20.
Oh, yeah.
Okay, so X is equal to 20, and now when we go to check it, you got 20 divided by 4 is equal to 5, and 5 equals 5. Check. Okay, so the big thing you need to understand is that if we're adding 4, the inverse operation is subtracting 4. If we're multiplying by 4, divide by 4. If we're, okay, it's always the opposite. All right, E. Brian. Right now, we've got an x here, Brian. What would be the inverse operation that is happening after it? Division. So he says this sign right here means multiplication or division because he wants to do the opposite of that. What sign is that I circled? Subtracting. Would you agree that that's subtracting? What's the inverse operation to subtracting 12? Addition. So if one thing says subtracting 12, we are going to add 12. So add 12, add 12. The 12s cancel. Does it bother you that x is on the right side of the equal sign as opposed to the left side of the equal sign?
No.
No. So it shouldn't. All right? What's negative 3 plus 12? 9. 9. Anybody else? Negative 3 plus 12. 9. Okay, so we got 9. All right, so x is equal to 9. And then don't forget to check that. Okay, so when you go to check it, make sure you have negative 3 equals 9 minus 12. 9 minus 12 is negative 3, which also equals negative 3. Check. Okay? All right? Questions? All right, so big ones that you have to pay attention to are C, okay, with, the variable and the letter in a different order. Pay attention to those. All right, on the back side, we talked about the multiplicative inverse in chapter 1. Does anybody remember a synonym for it? Or another way of explaining it? Do you remember? No? Tanya, you remember? Victor? No? I remember talking about it because I kept using this symbol. And you guys used what word? Daisy, say it louder. Flip. Remember that when you do the multiplicative inverse, it is basically your reciprocal. Your reciprocal means that you flip it. Okay? So whatever word, reciprocal seems like a big word if that's too tough for you. Okay? Use the idea of flipping it. Now, some people get stuck with this, okay, in terms of if negative 2/3 is my beginning number and I flip it, what should I end up with? Should I have a positive or a negative as part of my multiplicative inverse? So what would you have?
Over
Negative 12?
negative 2.
All right, so 3 over negative 2. Do you agree with that?
No.
No? All right, so Lynette, what would you change it to? Did we flip it?
Yes.
Did we keep the sign the same? All right, so here's our check. They should multiply to equal a 1. What is negative 2 times 3?
Negative 6.
What is 3 times negative 2?
Negative 6.
Is negative 6 divided by negative 6 equal to 1?
Yes.
Then that means that 3 over negative 2 is the multiplicative inverse. We flipped it correctly, okay? That's our way of just checking it, okay? So, over here, you have just a whole number 7. Tanya, do you know what the reciprocal or the flip or the multiplicative inverse of that would be? She says 1 over 7. What do you think about that, Aaron? You think it should be a 1 over 7? No? Diana, what do you think? Okay. Can anybody take the number 7 and put it in the form of a fraction for me?
Yes.
All right, how would you do it, Diana? So, if it's 7 over 1 is 7, then when I flip it, would you agree that it's 1 over 7?
Yes.
All right. Okay. Would you agree that if I multiply across, that would equal 1? All right. Then, last one. Negative 1 over 7, the multiplicative inverse would be, Victor? So, Victor, we flipped. Negative 2 over 3 became 3 over negative 2. 7 over 1 became 1 over 7. So now you got negative 1 over 7. Can you flip that for me?
7 over -1.
Good job. Easy peasy, right? Okay, and they're gonna multiply out to be a 1 because of -7 divided by -7 is a 1, okay? All right, so how does that apply to what we're doing here? Okay, if I wanted to solve for x, how can I get rid of the -2/7, or how can I change that into a positive 1, like the 3 examples above? Lynette? We could, okay, like Crossy divided with the 1/4. But how do you divide fractions? How do you do that? Do you remember how to divide fractions? Multiply by the,
Like, you switch it and then you multiply like 7 times 7 into -2 times -2.
so he's saying basically if we multiply by the flip, you get a 1x. Do you agree with that? What's 7 times -2?
-14.
What's -2 times 7? What's -14 divided by -14?
1.
So 1x. That's the whole point of what we just did, okay? That would be the same thing as dividing by -2/7 and dividing by -2/7. But when you divide by a fraction, you multiply by the reciprocal, okay? So instead of doing the dividing, why don't we just skip the step of dividing and go directly to multiplying by the reciprocal? All right, so we did this in the last chapter. We multiplied 2 fractions together. How do I simplify? How do I simplify?
Find a common multiplier factor.
Do I need a common denominator to multiply?
No.
No? When do I need a common denominator?
Adding.
Adding and subtracting. So I'm not adding or subtracting, so I don't need a common denominator. So how do I multiply?
Or multiply?
You can divide the 4 with you as when you always say.
Okay, I can cross simplify, or I can, in general, do what?
Multiplying and after simplifying.
Yeah.
Multiply, and how do I multiply? By going
Across.
straight across. All right, so one thing that I could do, I could multiply straight across and get 28, multiply straight across and get -42, but now I gotta simplify 28 and 42, okay? What Roxana was trying to say is, if you remember in the last unit, we did that cross simplifying. She wanted to simplify 7 and 21. So, Roxana, what number goes into 7 and 21? No, 3 doesn't go into 7.
Wait, there's nothing.
Yes, 7 goes into 7 once. 7 goes into 21 3 times. What number goes into 2 and 4?
2.
2. 2 goes into 2 how many times?
2.
Once.
Oh,
2 goes into
yeah.
2 goes into 4 twice. And now I can multiply 2 times 1 and get 2. And then 3 times a -1, don't forget about that negative sign, is a -3. And so now x is equal to -2/3. Now, how can I get this to become -2/3? What would I have to divide by? Anybody know? I'll throw it out there for 1 point extra credit if anybody can tell me the number. Because we talked about the idea of the GCF.
6. 8. 9. 12.
3, 2, 1. Anybody?
4. 6. 14.
Who said it?
14.
14 is correct. 14 goes in twice and 3 times, so it's -2/3, okay?
I said 14.
All right? Okay? All right, so, like I said, when we get to the backside, it was going to be a little bit more difficult, so, you know, those people that are schnoozing, okay, you got to focus a little bit more, okay? In fact, this B example is not a 1-stepper. It's actually going to be a 2-stepper. Let's see how good you are with this one. Ideas on B. Maria, what do you think?
You have to multiply by 3.
Okay, she says the opposite of dividing by 3 is multiplying by 3, so she wants to multiply by 3. If I do that, what am I left with? Negative x. What's 3 times negative 2? Is it okay to have negative x?
And then you
Divide by
negative 1.
negative 1, divide by negative 1, and x is equal to 6. Now, for most of you, you're probably going to do it that way, and it'll end up being a two-stepper. There is a way to get this done in one step, though. Does anybody know how to do that? Yeah.
You just 3 times negative 2 because there's the fraction in x.
We did 3 times negative 2. Anybody? All right, so how about we look at this as a negative 1/3 x? What's the inverse to negative 1/3?
3 over 1.
Negative 3 over 1. If I multiply a negative times a negative, what do I get? A positive, and then a negative 2 times a negative 3 would be a positive, and I can get it done in one step. So instead of, okay, if it's too, I got a lot going on here. If it's too confusing, what I'm basically saying is, the first time we multiplied by 3, but if I had multiplied by negative 3, the negative times a negative would have yielded a positive, and negative times a negative would yield a positive, and we would have gotten x equal to 6 in one step, okay? So I just want you to realize that even though the negative is not next to the 3, you can still use it, okay? All right, C. We'll stop with this one if we do well on it. What do you want to do?
So for B, you got x equals 6.
Yes, x is equal to
But when
6.
Never mind.
You want to check it? We got out of the habit of checking it. Let's check it. Okay? So remember how negative x is the opposite. What would the opposite of 6 be? What's the opposite of 6? So I would write negative 6 over 3 equals negative 2. What's negative 6 divided by 3? Negative 2 equals negative 2. Check. So it works. Okay? So it does work when you plug it back in. Was that your question?
I didn't saw the negative.
Yeah, you need the negative, yeah. Okay? All right, last one, C. Ron, what should we do here? Okay? And are we going to add, subtract, multiply, or divide? All right, so he says multiply by the flip of 3 over 5, which is 5 over 3. Okay? All right, and so now these cancel. We're left with x. If you don't like doing the cancel idea, remember that this is 15 divided by 15, which is 1. Okay, however you want to do it. Now, did you like the idea of multiplying across and then simplifying, or do you want to simplify first? Simplify first? Okay. If we're going to simplify first, is there a number that goes into 5 that also goes into 25? 5. How many times does 5 go into 5? No. 1. How many times does 5 go into 25? How many times does 5 go into 25? 5 times. You guys need to work on your skills a little bit. Okay? So now, negative 1 times 1 is negative 1, and we've got 5 times 3, which is 15. So x should equal a negative 1/15. Okay? And then we can check it. 3/5 times negative 1/15 equals negative 1 over 25. Negative 3 times 1 gives us a negative 3. 5 times 15 equals 75, which is negative 1 over 25. Would you agree, if you're good with money and quarters, that 3 goes into 75 25 times?
Yes.
Okay, so then guess what? This simplifies down to 1 over 25 equal to negative 1 over 25. Check. Okay? All right? questions.
It could be either one. And that's not bad.
Well, you should go all the way down to where the left side equals the right side. Show that it works. What do you mean, either
We
one?
just got -1 over 13.
That's the correct answer. We plugged it in. That's how we got this.
Oh, are you supposed to plug it in?
Yes, that's the checking.
Do you have that chuck in your?
Yes,
Oh, you.
yes.